All right. Hello and welcome. Today I'm going to discuss forces in two dimensions, and then I'm going to solve the hanging sign problem. And also this helps you with homework 1211. All right, so let's assume you've got an object and there are two forces on the object. We're going to call it FA and let's make up something crazy, FZ, just to mess with us. All right, FA is equal to, we'll say, 10 newtons. FZ is equal to, we'll say, 13 newtons. And to find our answer, we'll need this angle, which we'll say is 130 degrees. So the problem would say, find the net force and the equilibrant. All right, so here we go. Finding the net force. Follow along with the steps of solving these problems. First step is to simply find the sum of the forces in either dimension. Let's pick the x dimension. Now, what forces are acting in the x direction? Is FA in the x direction? Nope. Is FZ? Kind of, but only a small component of it. And we're going to call this FZ sub x. So we come over here, write FZ sub x plus, so there's nothing else. Nothing else, so that's it. FZ sub x can be simplified to FZ, so the magnitude, 13 newtons times the cosine of what angle is this? Should be 50 degrees. Times the cosine. I could write the cosine of theta, but we solved for theta. Let's plug in 50 degrees. There we go. FZ is 13 newtons times the cosine of 50 degrees. Let's get the calculator out. This is awesome. 13 times the cosine of 50. All right, so I got out in my calculator 8.36 newtons. Now let's see what's wrong with that answer. Okay, this is the sum of the forces in the x direction. I got a positive 8.6. Something's wrong. Okay, I need to make this negative because look at FZX. It is negative. All right, next step is to find the sum of the forces in the y direction. Let's write our equation up. Sum of the forces in the y direction is equal to the y component, we call it FZY, of f of z. So we call FZY plus f of a is going down. And f of a is negative, we'll have to remember. So with that information, let's solve this. FZY is going to be FZ times the sine of our angle 50 degrees plus a negative 10 newtons. Let's continue to solve for this. We got 13 newtons times the sine of 50 degrees plus a negative 10 newtons. This now can be solved. 13 times the sine of 50 minus 10, or plus negative 10, comes out to be a very, very small number, actually. Comes out to be negative 0.04 newtons. So who won? FZ Z or FA? Looks like FA won slightly. Okay, FA was 10 newtons. And watch, what I'm going to do is I'm actually going to solve for 13 sine of 50 to see what we get. 13 times the sine of 50 is equal to 9.96 newtons. And we're adding that to negative 10. So you can see now the negative 10 is greater than the force of Z in the x direction. And we get out 0.04 negative. All right, so we have our x and our y. Looks like we're getting two negative numbers, which is cool. Our x was 8.36. All right, we got this. I'm getting tired, but it's awesome. All right, so let's rewrite this. Sum of the forces in the x direction is equal to negative 8.36 newtons, and the sum of the forces in the y direction is equal to negative 0.04 newtons. Now let's draw this. So we got our object, and we have a sum of the forces in the x direction to be negative 8.36. And the sum of the forces in the y direction is just this tiny bitty sum of the forces in the y direction is negative 0.04 newton. All right, so there's our sum. We're looking for this value. Nope, not that value. Nope, not that one either. We're looking for the resultant between the two. How do we find the resultant between two vectors? We're looking for this right there. We obviously can see that is what it's going to do, but let's actually show it. What you do is you take the tail of one vector, doesn't matter which one, and you add it to the head of the other, and look, it makes the triangle we're looking for. Now check this out. Either one would work. Let's add this one to that one. Look, it makes the same triangle, right? This line is the same no matter what. But let's get rid of this one and stick with that. So now we can actually take this and move it over here to be the sum of the forces in the y direction is equal to negative, yeah, you got it here, negative 0.04. So what we're looking for is the net force and the angle that it's acting at. So let's Pythagorean theorem this bad boy. You get the square root of sum of x squared plus the sum of the forces in the y direction squared, and you get out the square root of negative 8.36 newtons squared plus negative 0.04 newtons squared. And your final answer is negative 8.36 squared plus 0.04 squared. And you get out a number just slightly bigger than 8.36 because the numbers are so close. 8.36, we'll round it a little bit to 1 newtons. All right, very good. So that's the magnitude of the net force. Now the angle, theta, is equal to inverse tangent of opposite over adjacent, which in our case is tangent inverse of negative 0.04 and negative 8.36. What do you predict the angle to be? Really small or really big? I'm guessing really small, like baby. 0.04 divided by 8, 8.36. And you get out 0.27 for your angle. 0.27 degrees is this angle right here. So your final answer is going to be net force is equal to 8.361 newtons at, let's see, which direction was that angle in? Looks to me like south of west. Let's look at our picture. That seems to make sense. So at 0.27, so not even a whole degree south of west. Now the equilibrium, what's the equilibrium, you may ask? The equilibrium is the opposite of this. So it's going to be 8.36 newtons at 0.27 degrees. North is opposite of south of east. So that means basically this force, the exact opposite. All right, there we have it. The net force and the equilibrium of that problem. Now I'm going to run through real quick the solution to, or just probably the biggest key